The technologies that COBALT's testing right now will one day enable NASA to send robotic or human spaceflight missions to land on Mars, the Moon, Europa, or other solar system destinations where we want to target landing in very hazardous or precise regions such as canyons, craters, on cracked ice fields, close to geysers, or other geological or scientifically interesting locations. So COBALT stands for Cooperative Blending of Autonomous Landing Technologies. The project is focused on integrating and testing two complementary sensors or instruments, one the Lander Vision System LVS and the other the Navigation Doppler lidar NDL.
And the way it works, it actually uses its camera to take images as it's coming in to land and compares them to its onboard map. And by doing that, you can actually now determine where you are on the map of where you're trying to land. So that allows you to do a number of things. One, it allows you to actually more precisely determine your actual position coming into landing, and then you can actually do diverts to actually land where you want to land. It also allows you to detect and notice things like hazards and actually divert around those hazards as you come into land.
Laser coming on.
And give the spacecraft essentially a set of eyes. So as it's coming into land, it's actually enabling its processor and its computer to see where it's actually going.
Laser's on.
We'll be conducting two different flight campaigns within COBALT. One is open loop and the other is closed loop. The difference being that during open loop, the vehicle is not utilizing COBALT's navigation for planning its maneuvers. It's instead utilizing GPS. During the closed loop campaign, the vehicle will actually rely on COBALT navigation.
Copy that. Okay, moving to the engine start page. COBALT, this is LC. Go, no, go for flight. Pilot, prime engine.
Prime engine.
Okay, team, here we go. Masten off to all. 6-second countdown. 5, 4, 3, 2, 1. Ignition.
During our flight testing, we take off at one location and then we target a landing site that's 300 meters away. On takeoff, we ascend up to a 500-meter altitude. During that time, our Navigation Doppler lidar begins sensing velocity and range within the first 5 meters of altitude. The Lander Vision System begins performing terrain relative navigation at about 50 to 100 meters altitude. So during the ascent, we're getting initial measurements and starting to generate the COBALT navigation solution. After we reach the 500-meter altitude, the vehicle reduces the engine throttle, the engine thrust, and starts falling back towards the Earth to build up velocity. Once we hit a 25 meter per second downward velocity, we execute a divert maneuver that targets a specified landing location 300 meters downrange. The vehicle then navigates until about a 20-meter altitude above that landing site, and then executes a vertical descent to touchdown. This is all autonomous on Masten's GPS-based navigation for open loop, and then during closed loop on COBALT's navigation.
Yeah.
All right.
Yeah. All right.
All right. Good job, Steve.
No such awesome.
Well done, sir. Well done. So Masten's out here at the Mojave Spaceport. We're supporting NASA's flight opportunities by testing different technologies here in the desert that are hopefully landing on another planet one day. So when you have your payload and it's going to go land on Mars, it's really nice to know how it's going to function in that landing environment, propulsive landing specifically, which is something we have not done on another planet yet. So instead of taking the risk of sending something all the way to Mars and not knowing whether it works, We can come out here in the desert. Flight Opportunities provides the payload with the ability to come onto our rockets and do a similar type profile to what they will see when they go to land.